Um, now that I can finally write on the board. Unrelated to this stuff, can you guys do this one as a warm-up? I keep checking that you know how to do that. Can I raise the power and divide by the new power? No?
Good morning. Pardon the interruption. Teachers, please remember to come and pick up passes from your mailbox today as soon as possible. Thank you and have a wonderful day.
Okay, how do I do this? Nick? It's a circle. Is it an entire circle?
It's a quarter of a circle.
Okay, so this was in chapter 5 when we first started to learn integration, and I threatened to put the idea on the chapter 6 test when you had comfortably forgotten about it. I tricked you all and I put it on the chapter 5 test, and you had already forgotten it then. So keep checking now. We can't ever, with what you will know in BC Calc, integrate this by hand. However, you can know what the shape looks like geometrically.
Good morning, Baron. Pardon the interruption. Teachers, please remember to come by and pick up the passes from your mailboxes for today as soon as possible. Thank you and have a wonderful day.
I don't know what passes they're talking about. So what's the area of that quarter of a circle? Pi r squared. IR squared. Radius in this case is 3, and as Nick said, we want a quarter of it. Okay. So there's that. 15 on the sheet you were given, I believe it said that calculator question. You looked at the answer in the back of the book. Clearly, it can be done by hand because it was a nice answer. So Jasper, dx slices or dy slices? Dy slices. All right, so So I'm gonna look at y stuff, and I'm gonna integrate from the lower y value to upper y value. It's gonna be a circle, so I need pi r squared. The radius is given to me nicely already. And then enters calculator, or we remember some trigonometry. What's a trigonometry that has tangent squared in it?
One whole secant. Oh, I was just gonna say what tangent squared is equal to.
Okay,
Oh, sorry. That's what I meant.
tangent squared of stuff plus 1 equals secant squared of stuff. So let's see, why is that helpful? Well, I happen to know somebody that's got a derivative of secant squared. I don't know what tangent squared equals, but I can't integrate that one. So integral of secant squared? Tangent, just tangent. Chain rule. Normally I would have, in doing the derivative, I multiply by the derivative of the stuff inside, so integrating, divide by the derivative and stuff inside, so Hadley, what am I dividing by?
Pi over 4, so multiplying by 4 over pi.
Dividing by pi over 4, so multiplying by 4 over pi. Integrating this -1 is y, and evaluating from 0 to 1. Tangent of pi over 4 is 1, so that's 4 over pi, minus 1, that's a 1. Now plugging in the 0, tangent of 0 is 0, subtracting 0 is still 0. So it comes out to 4 minus pi. But if you use the calculator, got that 0.277 or whatever it is. Were there issues with the other problems that we need to go? There's a quiz tomorrow on 7.1 to 7.3. You guys have questions on any of this stuff? Yeah.
Are you sure what's the disk method is the, when you're finding the, r of x equation, is that always, pi times the radius squared, which would be, the radius would be, the equation, or do you have?
Hi. I sent you a message.
Okay. That was easy then.
Yeah.
Thanks.
Thank you. Okay. For all of these problems, doing disk method, which the next thing coming up is washer method. You guys know what a washer is? What's a washer? It's a circle with a hole in it. So disk method means the circles are solid. So it's a whole circle, and it's just pi r squared to find the area. Washer method, which might be some of the mean, you got a circle with a hole in it. So it's the area of the big circle minus the area of the hole. That's all. So how we do any of these, you need an equation for the radius, because these circles, in this case, are getting smaller. So if it's a static circle where the radius doesn't change, it's just pi r squared. Radius is 3, 9 pi. But if the radius is changing and we're going by, as I keep asking, the x slices, I need this equation for the radius in terms of x, with x values in it. If I'm going this way, I need the radius in terms of y. That's all. And sometimes it's complicated finding what that radius value is because it will be, I don't know. Where are these rotated around the x-axis? Okay. Alex, pick a number, 17 or 18?
18.
So the problem originally asked around the x-axis. Can you guys set up and solve revolving around the y-axis? Try that. Let's see what. Anyone draw the shape for us? Yes, it's that. So, there's a reason they said x-axis, not y. What's the issue? There's gonna be a hole, it's gonna be a washer method. Okay. So Nina drew y equals x cubed. And the line y equals 0. And x equals 2. Okay, and then I asked for that to be spun around that guy. Okay. As you guys said, there's a hole in it. Pick a number.
3.
Josh, pick a number bigger than 3. How would we find the area of that ring? Ready? Sorry? So pi r squared of the big one minus pi r squared of the inside one. So 25 pi minus 9 pi, 16 pi. All right, well, let's see. Can we do that with this shape? Biggest radius? What's the big radius? 2 doesn't change. It's not an equation, like not a function of x or y. No. So the big radius is 2. So the area of the outside thing is going to be 4 pi. Sophie, what's the equation of the little radius? I need to find the distance from this curve to the y-axis.
Oh, do you subtract it? Do you do like the x, the rightmost, and then minus like x equals 0?
Right minus left.
Right minus left.
So do I need x equals or do I need y
You
equals?
need x equals. So
Okay.
you can find like the y points. So
So the radius of the little guy is y to the 1/3. So like Grady just did with the static numbers, I'm gonna find the area of the big radius, area of the big circle, minus the area of the little circle. What kind of slices? Y or X? Y values. And what is that coordinate? What's the Y value right there? When X is 2, Y is 8. And the Y value down here was 0. So capital R squared minus little r squared. So integrate each and plug in numbers. That's the washer method. Just wanted to see if you guys could do the Y's business, and I chose values wrong. Anyway, yeah.
The little r being y to 1/3, but why wouldn't it be 2 minus y?
Okay. When Grady did this one, did he do 5 minus 3 and then square? No, because whereas this distance is 2, it's not centered here. So it's got to be big radius squared minus little radius squared. Yeah.
Why did you integrate from 0 to 8?
What? Okay, where are the y values? Right here is the bottom of the shape. The y value is 0. And here, where does x equals 2 and y equals x cubed intersect? Well, plug in 2 for x, 2 cubed, 0. The y value is going to be 8 there. It does not on the scale. Very poorly drawn. Okay.
Is washer method on the quiz tomorrow?
Is it on the test next week? Yeah. What is on the quiz tomorrow? I haven't written it yet, so you tell me. Wondering where files are. So this is 7.1, which is a repeat of other stuff. Do you know when things move right, left, and when they're stopped? What do you have to look at? Camden, what do we have to look at to know if something is moving right, left, or is stopped? What is it? You used a pronoun. I don't know what it is.
Like if the graph is positive.
I don't have a graph. I don't have a function.
If the function is positive, then
What
negative.
function? I could have position. I could have acceleration.
Velocity.
When velocity, there you go. Please don't ever use pronouns on the AP exam. They will just destroy you. And as the grader, I have done that, and I feel so bad. I'm like, oh, but I know what they mean. No. So how you know when a particle's moving right, left, or stop? Now look at velocity. If I gave you position, how do you find velocity? Derivative. If I gave you acceleration, how do you find velocity? Integrate. Okay. So Jamie, this one, they gave us velocity, so, wait,
You have to like find the zeros.
Okay.
Or when it's 0. And then you can like make it up.
It's not cost, it's cosine of t. When does cosine equal 0? Pi over 2 and anywhere else in that range? 3 pi over 2. So that is when the particle is stopped. And cosine's positive in quadrant 1, negative in 2 and 3, positive again in quadrant 4. So when is it moving right? When is it moving right?
When it's positive, so 0 to pi over 2 and greater than 3 pi over 2.
Okay. And reasoning. You can be as terse as that, but don't tell me it. Because v of t is greater than 0. That's as succinct as you can say velocity is positive. When is it moving left? The particle is moving left from pi over 2 to 3 pi over 2 because velocity is negative. How do I find displacement over the time period 0 to 2 pi? Am I gone?
Sorry, absolute value would be integral.
I want displacement. Is that absolute value or not? That's the key question.
I'm sorry, not absolute value.
Not absolute value. Just integrate. So just integrating whose derivative is positive cosine, positive sine, evaluating from 0 to pi. Y'all went nowhere. You ran around the track and came back to where you started. Alex, how do I find this, or total distance? No calculator.
Absolute value of the interval.
Okay, absolute value of this, but if you need to do it by hand on the test quiz tomorrow, because I'm not gonna give you a calculator, how do I evaluate that? By hand. Sean, how do I do it by hand?
Break down 2 equations.
I need to break it into a couple of equations. What specifically? Sean? There's some hints on the board. I need to know when the squirrel turned around and started running backwards, because I need to say, you ran this far forward, and then you ran this far backwards, and then you ran this far forward again. Sophie,
You
what
have
do I
to
do?
like do like 0 to pi over 2 and then the absolute value. Do you only put the absolute value then on the pi over 2 and 3 pi over 2 because it's the only negative part? And the rest of them you typically don't have to.
Okay. There are choices. In the land of set up but do not evaluate, which is often what happens on a non-calculator portion, how would you do this as a group of them? You know, what were you going to say?
I would do integrate from 0 to pi over 2, and then integrate from pi over 2 to 3 pi over 2, and integrate again from 3 pi over 2 to 2 pi.
So Sophie said, I think much the same. Sorry, backwards. So Sophie said, the positive things don't need the absolute values. How do I know they're positive? Well, that was the point of the other question. The first one saying, when is it moving to the right? When it's moving to the right, the interval is going to be positive. So that's good. Then we have choices of how to deal with that middle. Sophie said we can just add this can integrate that, and I'm gonna get a negative number and make it positive. Nina, you said, did you say to reverse the bounds, or?
I just said that I would do it separately, but you can make it negative.
So I could say -5 and then reverse these bounds, make it 3 pi over 2, positive pi over 2, and then this negative area became positive because I'm going backwards. So there's choices. But that would give you total displacement. It adds your area up and says, you know, squirrels were in a Fitbit, squirrel ran a mile that way, mile this way, ran 2 miles. So net versus displacement. Sorry, displacement versus total. Questions about it, or are you guys okay? Justification, don't use pronouns. So that's the gist of 7.1. Often the way they will ask, they will give you some real world model of, hey, here is like something that models the flow of water in a tank. And it's got a leak in it, but it's raining and it's filling. What's the amount of water total amount of water that flowed in? I'll ask stuff. Area between curves. Be able to set up if we not evaluate if it's ugly numbers. Claire, how many integrals will we have to set up for this one? 2, because the top and the bottom trade once. So this one would be red minus blue, or purple, whatever, and this one would be purple minus red. And finding the intersection points, or maybe they're given. I don't know, you guys feel good with tomorrow?
Do we have to know the trig identities?
You need to know the Pythagorean identity, like 1 minus cosine squared is sine squared, sine squared plus cosine squared equals 1. To integrate by hand any of like sine squared and cosine squared, it's helpful to know the cosine double angle formula. The AP does not stress that. And knowing the tangent squared trick that we did today, it's good if you can do that. All right. So we just did this kind of problem. So I'm gonna move on. If you guys don't have questions, I don't feel like I have the area or the latitude to skip class time. So again, this is now washer method, what we're leading up to. And Brady already did this one. So you have to do the area of the big circle minus the area of the little circle. Yeah, Nick.
Washer method 7.3 is that?
It is part of 7.3. It's not on the quiz tomorrow, but it's on your test next week. So I don't want to overcomplicate things because these just look not pretty. So the area of the face of the donut is the big radius squared minus the little radius squared. If you just subtract the radiuses and then square it, it's super duper not correct. Because 9 minus 3 is 6, which is 36 pi would be the area of a radius with radius 6. But this is 81 pi minus 9 pi. You're off by a lot. So washer method, you need to figure out what is the radius so from the spinning part, wherever it's spinning outside the most, and then you need to find out what's the radius of the hole you need to drill out. So it's what I just showed you guys. But the big radius squared minus the little radius squared times pi. Don't lose pi. Have any of you tried the GeoGebra links that were posted? They very much help in trying to visualize what's going on.
Oh, never mind.
Good job. Okay. Big radius squared minus little radius squared, integrated from whatever bounds you're given. All right. So let's try it. Can you draw it? Not the best. So we have x squared and square root of x, right? Oh. All right, struggling with the app here. But you guys should know what the graph looks like, right? Square root of x and x makes that little petal looking thing. Nope, stop spinning. If I want to spin this shape around, there's just one cross section. I'm trying to make the image bigger and it's doing funny things when I try to move. Oh, that's fun. All right. Well, good times. Not a great picture. Can anyone tell me what the equation for the large radius is? What's the distance to the furthest away curve? The curve that's on the top? is square root of x. And what's an equation for the little radius that we need to drill the hole? Also,
It would be x squared.
x squared. So the volume of the shape is big radius squared minus little radius squared. From 0 to where do they intersect? At 1, and I'm missing something. It's the thing that people do wrong on this one all the time. What am I missing? Pi. All right. To integrate square root of x squared is x. Raise the power, divide by the new power. So it's pi times 1/2 minus 1/5, which is, what is it? 3/10. 5/10 minus 2/10. Don't forget your pi. Okay, so that's the washer method. Crazy? It takes practice to make sure that you don't lose pi. And the radiuses will start to get complicated. Because if I made this spin in the air, like spin around y equals 3 or something. Oh, here we go. The same shape spun around y equals 2. What does that shape even look like? So it's small, but oh, great. As I was saying, it helps visualize. It really didn't. But it's rotating around this thing, so so it kind of looks like this guy with a curved in edge. Now it's a much harder question. The large radius is this guy. How do I get an equation for that? Favorite?
I just looked at it and it looks like negative x squared plus 2.
Okay. I'm gonna do top minus the bottom, which is exactly what you said, but to me it makes more sense to say, all right, well, how long is this stick? The top minus the bottom curve. Preston, how would we find the radius of the hole that we're drilling out? The distance from here to the green guy. 2 minus root x. All right. Pi times, and we're gonna integrate over what bounds? 0 to 1, okay? And it's big radius squared minus little radius squared. How do do what with them? You need to expand them. So that's where the problem comes in. All right. So try that. And tomorrow you guys have the quiz. We will start up with the washer method again on Thursday.